strangers from afar. Where might these come from? These aliens? This sculpture studio makes models of aliens for the movies. The creatures crafted here have appeared in over 20 Hollywood films. But extraterrestrial life isn't something that just exists in the movies.
I think it is without doubt in my mind that life has originated elsewhere.
地球外生命は必ずいるでしょうし、またいないと考える方が難しいです。
The whole rest of me is screaming that the universe is probably teeming with life.
Surely life exists in environments completely different from Earth's. As space exploration proceeds, scientists are growing more confident as to how they envision alien life. But what makes these scientists so sure that life does in fact exist in outer space? The answer must be sought on the cosmic front. Is our existence in this universe an isolated phenomenon? Or is space in fact teeming with life? For answers, scientists are placing great hopes on one of the moons of a planet far, far away. More than 1 billion kilometers from Earth lies the planet Saturn. Hidden amidst its rings is a moon with good prospects of harboring life. Here's a backlit view of Saturn. Beyond its familiar set of rings is an outer ring that is thinner and fainter. The E-ring, discovered in 1967. The bluish-white E-ring includes one extremely significant body circling Saturn. Enceladus, one of Saturn's many moons. Diameter 500 kilometers. Its bright white color comes from ice. Enceladus appears to be covered in it. This image of Enceladus was taken by the Voyager 2 spacecraft in the 1980s. Seeing it, many scientists were astonished. The moon's surface is remarkably smooth. The elimination of craters in some areas suggests massively transformative tectonic events. Could it be that whatever is happening on Enceladus has something to do with the E-ring? As we shall see, the very human desire to solve this riddle leads us to place great hopes on the existence of extraterrestrial life.
And liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
The Cassini Saturn probe left Earth in 1997. Its primary mission, to examine the relationship between Enceladus and the E-ring. Cassini's voyage to Saturn took 7 years. It reached the planet's vicinity in 2004. A quarter century after the Voyager mission, the mysteries of Enceladus are finally being addressed. In the western American state of Colorado is located the Cassini Imaging Laboratory. Here is where the imaging data collected by the Cassini probe are analyzed. The leader of the imaging team is Carolyn Porco. She says that starting with Cassini's very first image as it approached Enceladus, she was filled with astonishment. This was it. Enceladus appears darkly in this backlit image. Some might think the image anticlimactic, but Porco deliberately chose this backlit mode.
Some suggestions were that there might actually be geysers. There might be little volcanic kind of geysers coming off the surface of Enceladus, spewing tiny ice particles into orbit around Saturn and forming the E-ring. We, in fact, had planned our sequences of images to include observations where we're looking in the direction of the sun, so that if there was a plume of very tiny particles, we would be able to see it.
Here's an example of backlighting using a humidifier. We create a fine mist, normally invisible. But if we then shine a light on it from behind, the mist becomes clearly visible. This backlit effect was precisely what Porco had intended. Let's return to that first Cassini image. If we look closely at the south pole of Enceladus, we see what Porco had been hoping to see, a conspicuously bright portion. A month later, a backlit Enceladus was photographed once again. In the same location, one could clearly make out filaments of light, a plume being sent from Enceladus into space. Analysis of the images revealed that this plume extended more than 100 kilometers.
What really, I think, made everybody just stand back in awe was the magnitude of this phenomenon.
July 14th, Cassini began a major phase of research. Reducing altitude to 168 kilometers, it made detailed observations of the terrain near the south pole of Enceladus. The mysterious moon then displayed features that even Porco had not anticipated. A number of vertical blue streaks. No craters at all, just this series of parallel fractures stretching for 130 kilometers. The anticipated volcanic topography was not present, but it was equally clear that the area had seen robust geological change.
It looks totally different, unique. Not only did the imaging team get this incredible look at this region that no one had ever really seen before, which is the south pole of Enceladus, and not only did we find that it was geologically unique, it was characterized by this set of fractures and was crater-free, very bright.
The team called the blue streaks tiger stripes. The tectonic activity across this area was indicated also by the surface temperatures. The average on Enceladus is -200 degrees Celsius. But the tiger stripe showed a dramatic increase to minus 80 degrees Celsius. Some researchers estimate that the highest portions of that area rise to minus 20 degrees. Furthermore, the nature of the plume was revealed. Analysis of the data showed it to be comprised mainly of ice and water vapor. Conclusive images were also recorded. Clearly, what had looked like perhaps a single flare actually incorporated more than a dozen individual jets or geysers. Moreover, the jets were issuing along the tiger stripe fractures. And the material they released into space has been forming one of Saturn's rings. The bluish-white E-ring is thus a band of ice chunks formed by high-volume eruptions of ice from Enceladus.
I keep calling it the Enceladus Interplanetary Geyser Park. You know, that would be a great place. That would be one of the sightseeing, top 10 sightseeing locales in the solar system.
If we could actually land on the tiger stripes, we would be able to see their jets ejecting ice and vapor from the ice fissures at fearsome speed, some 100 meters per second. Rising as high as 100 kilometers, they would present a thrilling spectacle. And many scientists have begun to believe that Enceladus must harbor life. Why do they think so? The Austrian Alps have an elevation exceeding 3,000 meters. Near their summits lie glaciers. One scientist thinks that this area bears a striking resemblance to the tiger stripes of Enceladus. Richard Hoover is an astrobiologist with NASA. This is a world of extreme cold, minus 15 degrees Celsius, even in daytime. An ice cave provides entry to the inside of a glacier. Sunlight cannot reach into the ice cave. This is a world of darkness, like Enceladus, which exists so far from its sun. "10 minutes into the ice. A huge space opens up.
It's incredible. Fantastic. This is absolutely magnificent.
This has been dubbed the Ice Palace. Huge columns of ice. Hoover posits that the tiger stripe area on Enceladus must look like this.
These spectacular ice stalactites hanging down from the surface and from the walls, these kinds of formations may actually be occurring in the tiger stripes of Enceladus also, where the ice crystals are forming and then under the gravitational field falling inward toward the center within the crevasses of these magnificent tiger stripes.
One sees no plants here, no animals, merely a world of extreme cold, a world of ice. It might appear that no life could exist in such an environment. But Hoover thinks differently. He extracts an ice core and carefully bags it. The ice he brought back from the ice palace is melted in its hermetically sealed bag and then analyzed. First step, microscopic examination.
Nice motility. Wonderful. Blinking right here. This is a bacteria swimming. You see? Yeah.
Microorganisms living in a world of ice. Here too, nothing but ice, it had seemed. Yet there was life. In his lab, Hoover preserved samples of ice collected from around the world, including the South Pole and Iceland. He has found microorganisms in all of these samples. This image conveys the fantastic capabilities of these microbes. The white images are microorganisms. The black background is the water. The membranes covering these creatures' cells is made of material that protects them from freezing. Rather than freezing themselves, they melt the surrounding ice. It has been confirmed that there are certain forms of life capable of existing in a minus 40 degrees Celsius environment.
I believe it is very possible that there could be life in the tiger stripes of Enceladus. They're much hotter than what anyone believed possible, and we now know that microorganisms live in glacial ice all over the planet Earth. Therefore, there could be microorganisms alive and thriving in the tiger stripes of Enceladus.
Considering the sheer tenacity of life, it could well exist on Enceladus too. Of that, Hoover is convinced. Carolyn Porco, leader of the Cassini Imaging Central Laboratory. Porco believes that truly potent conditions for life are present under the ice of the tiger stripes. She thinks there's a large body of water there, in its liquid state. Water. It's the reason there's life on Earth. Across our globe, all sorts of life forms use water in all sorts of ways. Porco is convinced a huge amount of water lies under the tiger stripes.
This was about 153. So
her conviction originated during analysis of the Cassini images, when she noticed something distinctive about the jets.
And that's why it's clear. It's clear here. You could see the extent of it, how big it is. What we're seeing in these images of the jets, those are tiny ice particles, and we see so much of the solids compared to the vapor that is detected by the other instruments that the most plausible way to get that is from saying that the material starts out as a liquid and the liquid droplets eventually freeze and become the particles that we see.
Measurements show the diameter of the particles to be less than 1/100th of a millimeter. If these geysers were shooting out only broken up bits of surface ice, it is difficult to explain how so many particles could become so small. But if it was water that was gushing up, freezing after the spray had become droplets, then that would explain the large quantity of ice particles. But Saturn, around which Enceladus revolves, is 1.4 billion kilometers from the Sun. That's 10 times farther away than Earth. That's why the surface temperature of Enceladus averages minus 200 degrees Celsius. any water on it would freeze, becoming ice. On this moon of ice, how could a large body of water exist in a liquid state? NASA's Jet Propulsion Laboratory, JPL, is located in the suburbs of Los Angeles. Inside is the control room for the Cassini space probe. Today they are again instructing the probe, 1 billion kilometers away near Saturn. Recently, Cassini has uncovered facts supporting the theory that liquid water is present on Enceladus. In October of 2008, Cassini drew very close to Enceladus on a low-altitude flyby. It was able to pass through the jets and to analyze their constituent matter minutely. One thing detected in the jets was ammonia. If ammonia is dissolved in water, it permits the water to maintain its liquid state even in temperatures as low as -97 degrees Celsius. In other words, it functions like antifreeze. But there is another factor melting the ice on this frigid moon. The movements of another of Saturn's moons, Dione. Enceladus revolves around Saturn on an orbit in between Saturn and Dione. Enceladus completes one orbit every 33 hours. It takes Dione exactly twice as long, 66 hours, to complete its own circuit. As a result, once every 66 hours, Saturn, Enceladus, and Dione are all lined up. Subjected to the gravitational pulls of both these bodies, the spherical shape of Enceladus is distorted into an ellipsoid. Then, as the alignment breaks up, Enceladus reverts to a sphere. When this happens enough times, the interior of Enceladus experiences a buildup of frictional heat. That melts some of the ice in the crust. It turns into liquid water. The hypothesis is that then, as the surrounding ice fractures, the water gushes out in jets.
Maybe a body of liquid under the surface of Enceladus. So the jets are an indication to us, actually, that we have on Enceladus a place where life might have gotten started.
An ocean under the ice of Enceladus, nurturing diverse forms of life. That's the vision of another scientist as well. Yasuhito Sekine is a scientist at the University of Tokyo. He believes that the warm environment of this ocean under the ice serves as a cradle of life.
エンケルダスが土星からの重力の影響を受けて歪むわけです。でその歪んだのがですね、氷の近くだけじゃなくて海の下の岩盤までおそらく歪んでて、そこで歪むことによって熱が発生すると。
Such gravitational distortions have huge consequences. Sekine believes that not just the icy crust, but the underlying rock is affected as well, producing frictional heat. Actually, the kind of seafloor envisaged by Sekine for Enceladus has a close counterpart right here on Earth. Here, the seabed is 1,500 meters below the surface. Volcanic activity expels water heated to 300 degrees Celsius. These are called hydrothermal vents. Here, in a world of darkness beyond the reach of the sun's rays, hydrothermal energy nourishes a variety of life forms. Sekine hypothesizes that Enceladus too has an environment like this, one that gives rise to a distinct ecosystem. In 2009, Cassini observation data were announced, data that apparently supported Sekine's hypothesis. An article in the science journal Nature detailed the elements composing the jets of Enceladus. This graph compares the constituents of comets, which are thought to contain the ingredients of planets, with the constituents of the jets of Enceladus. The amounts of methane, ammonia, and other constituents are similar. The article also pointed to the possibility of a constituent unique to Enceladus: molecular nitrogen. Sekine believed that the presence of this molecular nitrogen proved the presence of hydrothermal vents.
窒素というのはもともとエンケルダスの作った材料物質にはということが分かっています。実際どういう条件でその窒素が生まれているのかということを調べるっていうことは、それはすなわちそのエンケルダスの中の海の環境を特定することができると。
Molecular nitrogen be produced? It's been a week since the experiment started. What has happened to the material subjected to this high-temperature, high-pressure environment? Finally, the component analysis.
どのぐらいで結果出る？
もうものの数分ですね。出てきましたね。ほぼ窒素間違いないですね。
Molecular nitrogen, the same component found by Cassini.
嬉しそうですけど、どうですか今？
そうですね。ここに今ちょうど見えてるピークっていうのが、まさに我々が目指してた窒素 N2 のピークになります。この結果を踏まえて考えると、エンケルダスの中の海の中にも数百度、数百気圧という非常に高圧高温の環境が実際あるんだということを多分示しているんだと思います。
Molecular nitrogen is generated by the decomposition of ammonia molecules. Ordinarily, ammonia is a substance that does not decompose at low temperatures. The presence of molecular nitrogen indicates a high-temperature environment. The hidden high-temperature, high-pressure deep-sea world on Enceladus. Life forms that can survive in similarly harsh environments have been found here on Earth. They were discovered at hydrothermal vents in the Indian Ocean.
暑いですね。こう思ってられないっていう。
They can survive in temperatures reaching as high as 122 degrees Celsius. Thermophilic methanogens are bacteria that thrive in high temperature, high pressure water.
非常にこういうメタン菌いてもいいなっていうのはかなり強く思いますね。はい、
もしエンゲラドスに熱水活動があって、水素が出るんだったらもうほぼ 100% 僕はいると思いますよ。
In fact, this experiment confirmed the production of molecular hydrogen, the energy source for methanogens. If organisms like methanogens exist on Enceladus, then hopes rise that this could lead to a world of diverse life forms.
メタン菌は生態系の底辺に存在する生き物なので、その生態系の一番底辺のものを食べるような生き物で、それをまた食べるような生き物ということで、生態系がそのエンケラダスにおいてもかなり複雑にというか豊かな生態系がですねあっても全然不思議じゃないと思いますね。
Enceladus is 1.4 billion kilometers from the Sun. Under its icy surface is an ocean of water. On that ocean's floor, hydrothermal vents similar to those on Earth, fostering a rich ecosystem based on life forms similar to methanogens. That's how Sekine pictures Enceladus. The clue was provided by the jets of Enceladus. And that faint outer ring of light in which Enceladus is situated reflects our shining hope that we are not alone in the universe.
太陽系の外の地球から20光年のところに地球のように生物が住める環境を備えている可能性がある新たな惑星を発見したとアメリカの研究グループが発表しました。
That was October 2010. This stunning news of an Earth-like planet that might be able to sustain life reverberated around the world. A planet like our own planet Earth, one on which life could exist. The discovery was made from the volcanic island of Hawaii in the Pacific Ocean. Mauna Kea, an inactive volcano, has an elevation of 4,200 meters. On its summit are perched astronomical observatories operated by the United States, Japan, France, and other countries. The Keck Observatory. Scientists used one of the Keck's telescopes, whose 10-meter aperture classes it among the largest in the world, to make the discovery. Stephen Vogt is a professor at the University of California's Santa Cruz campus. He's part of the team that found a planet that may support life.
So this is the Keck 1 telescope. This is where I do my planet hunting. Gliese 581g is a very special planet. It reminds us the most of our own Earth.
This very special planet that Vogt discovered. What sort of planetary body is it? The night sky is punctuated with points of light. Most are fixed stars outside our solar system, each shining with its own light like our own sun. One of them is this reddish star, 20 light years away. That means it takes 20 years at the speed of light for its image to reach Earth. It's only about 1/3 the size of our own sun. The planet that Vogt discovered orbits this star. Since 1998, Vogt has worked with Paul Butler of the Carnegie Institution for Science to observe this red star. The discovery of a life-supporting planet orbiting this star resulted from more than a decade of scientific observations. And then, there it was. A planet they designated Gliese 581g, triple the mass of the Earth, in orbit around its central star at a distance of 22 million kilometers. That distance is significant. To understand why, consider our own sun. And consider liquid water, the source of life. If a planet is too close to its parent star, any water on it will evaporate. But if it's too far away, the water will freeze. For water to remain on the surface of a planet, it needs to orbit its parent star at just the right distance, like planet Earth. The vicinity in which water can remain on a planet's surface is called the habitable zone. When Vogt tried to calculate whether or not the planet he discovered was inside a habitable zone, he determined that it was right in the middle of it. It was indeed a planet very much like Earth.
So the feeling of finding the first known planet that could support liquid water it's a great feeling. I mean, it was very exciting. We've been trying to do this for 15 years, so this is, for us, this is the end of a long journey in that respect. So it's a wonderful feeling.
At long last, the discovery of a planet that might have liquid water on its surface. However, even with present observation technologies, the best we can do is to estimate the planet's mass and location. The presence of liquid water on the surface cannot be confirmed by direct observation. Is there really water on Gliese 581g? One researcher is trying to settle this question using theory. Professor Shigeru Ida of the Tokyo Institute of Technology is using computer simulations to study planet formation. To look into the question of whether or not water is present on Gliese 581g, Ida has studied what types of planets can be formed by a central red dwarf star. Planets originate from clouds of cosmic dust and gas that group around a central star at the time of its own birth. As these dusts and gases coalesce, they eventually form larger bodies, planets. In other words, Gliese 581g is not, like planet Earth, composed primarily of rock. Rather, it's an ice planet, like Neptune. and yet one can still have high hopes that life does exist there.
惑星本体がほとんどが氷でできているので、ハビタブルゾーンまで来ればその氷は溶けて、つまり液体の水、つまり海がふんだんにあるような惑星になっているというふうに考えられます。
Ida believes that Gliese 581g was born as an ice planet in a cold region far from its parent star. In the course of tens of thousands of revolutions, it gradually drew closer, winding up in the middle of the habitable zone. The result was that the surface ice melted, becoming liquid water, creating an ocean planet. The amount of water on such an ocean planet would be quite different from what it is on our own planet. Look at a cross-section of Earth. It's made almost entirely of rock. The oceans make up just 0.02% of the total mass, a very thin layer. Gliese 581g is different. It's primarily water. In fact, water makes up over 50% of the planet's mass. The first planet ever to be discovered in a habitable zone, Gliese 581g. With a high probability of maintaining vast amounts of liquid water. Oceans bathed in the sunset-like glow of its red star. What sorts of life forms might we find there? What does a biologist have to say about life on Gliese 581g, an exoplanet outside our solar system? Takeshi Naganuma. He studies life forms in extreme environments like volcanoes and deserts. Given the persistence of life in such extremely adverse circumstances on Earth, he thinks extraterrestrial life must also exist.
グリーゼ 581g という惑星に生命が存在し得ると聞いた瞬間からもう僕の頭の中にはそこの星の生物生き物がぐるぐるぐるぐる飛び交ってますね。こういった惑星が見つかったらそこの惑星の生命を考えるのは当たり前でしょ。これ生物学者の本能ですよ。
1 month after the announcement about Gliese 581g, Naganuma is paying a visit to Ida. Naganuma is hoping to learn more about the environment on Gliese 581g, so that he can consider the question of life on that planet more deeply.
中心者の明るさとこの距離から言って G がちょうどこう真ん中
Ida's first step, to explain certain aspects of Gliese 581g's parent star. This brought up the question of the star's lifespan.
100億歳ぐらいというのはありえますね。だから生命が進化する時間としてはいくらでもあると。
Indeed, 10 billion years would be more than double the age of our own sun, which is only 4.6 billion years old. That would mean that Gliese 581g has had plenty of time to evolve complex forms of life. Ida says that Gliese 581g has plenty of water, but no land. The only rock on this planet lies deep within. With the ocean reaching depths of several thousand kilometers, there is no way that that rock could form dry land. Learning that there is no land there has convinced Naganuma that an Earth-like civilization could not develop on this planet. but the ocean would still be teeming with life, he says. What form would that life take? Let's take a look at the world of Gliese 581G as envisaged by Takeshi Naganuma. A vast ocean, no boundaries in sight. Within it, life. What are these? Creatures of Gliese 581G. They float near the surface, living off the red light by means of photosynthesis. Their flat shape enables them to process as much light as possible. Life exists not only near the surface, but in the depths as well. These tube-like creatures are an example. They move by propulsion, taking water in with their mouths and expelling it from their rear ends. At the same time, they filter plankton, from which they derive nourishment. Their flexible bodies can adjust to variations in water pressure, enabling them to range from the deep sea to shallower waters. And there would be an unexpected place where life could develop as well. Surrounding a planet that is triple the mass of the Earth, the atmosphere of Gliese 581G is estimated to be 100 times denser than Earth's. Naganuma points out that such a thick atmosphere would, in a sense, approximate a liquid, constituting a medium through which creatures could easily float. So airborne creatures might emerge as well. Naganuma calls this particular extraterrestrial life form ball shoots. Three eyes and a large brain. What kind of life would they lead, these skyborn aliens? This is the Gliese 581G sky and the life forms that dwell in it, as conceptualized by Naganuma. These ball shoots, short for balloon parachutes, produce methane and other light gases internally. By regulating the amount, they glide through the sky like hot air balloons above planet Earth. Or by expanding their bodies into the shape of an umbrella and then a parasol, they end their buoyancy and descend slowly like parachutes. They negotiate the skies at will, using their large brains and skillful bodies. But eyesight development helps evolve a totally different creature as well. One that puts its superior eyesight to savage use. That's right. These new glider creatures are carnivores. When they spot prey, they go into a power dive and spear their victim with their sharp jaws. Then they use their long tongues to suck out the brains of the ball shoots. a plausible view of life and death on Gliese 581G, whose long-lived son has given it time to evolve diverse life forms. Naganuma has concluded that life there would be dominated by big-brained creatures that one might as well call aliens.
Toても賑やかな世界だと思いますよ。空にたくさんの生き物が浮いたり飛んでたりするすごく賑やかな世界、僕はそんな惑星だと思います。いやー、そういう賑やかな空の下に行ってみたいですね。
The universe is teeming with life. That's a premise that scientists are busy turning into a conviction. Stephen Vogt, a co-discoverer of Gliese 581G, is himself setting forth on a new cosmic front.
So this is the heart of the automated planet finder.
Vogt has developed a device to search for planets like Gliese 581G automatically. You enter in the location of the fixed star near which you want to search for planets, and then it conducts the survey for you automatically. It's being installed at the University of California's Lick Observatory. The fixed star around which Gliese 581G revolves is a red dwarf star. Such stars make up nearly 80% of the Milky Way. So Vogt is confident that there must be many more planets like Gliese 581G that are capable of sustaining life.
So my expectations for the APF are that we will find many Earth-like or Earth-sized planets capable of supporting life as we know it. There's probably tens of billions of such planets in our galaxy, and so we hope to find the nearest ones with this facility. I know we'll find them. I'm certain of it.
The universe is teeming with life. Someday that will be proved by scientific observation. Vogt's passion will not permit him to abandon that quest. The scientists on the cosmic front lines of space exploration have detected places both within our solar system and far beyond it where life can exist. In space, worlds unfold beyond our wildest imaginings. They are merely waiting for us to discover them. Humankind has only just begun to challenge the cosmic front.